Okay, let's unpack this. Think about all the places your health information lives today. Maybe it's at your doctor's office, a specialist you saw last year, maybe the app tracking your steps, or even a device monitoring your sleep.
Yeah, it's just all over the place, right?
Totally, like trying to find one specific puzzle piece scattered across, well, I don't know, a dozen different boxes.
Mm. And that feeling of fragmentation, it's not just, inconvenient for you. It's actually a massive hurdle for healthcare itself.
Right. How so?
Well, to get truly coordinated, effective care, these different systems, they really need to talk to each other seamlessly. They need to share data efficiently, reliably.
And that core challenge, that's what we're calling interoperability.
Exactly, that's the goal, getting everything connected.
And today, we're diving deep into the standards and technologies that are specifically trying to solve this and really bringing that power of connected health information directly to your smartphone, focusing particularly on Android and what the near future holds.
Yeah, there's a lot happening there.
So, our sources for this deep dive, they give us a few different angles. We've got a critical look at the health data standards themselves,
Mm-hmm.
articles exploring how Android is actually building features and developer tools for this.
Right, the practical side.
Some really crucial insights into the security landscape, which is obviously huge when handling such sensitive information.
Absolutely critical. Can't forget security.
So let's start with the foundation, maybe, because healthcare data exchange, I mean, it isn't exactly a brand new problem, is it? There's been an old guard in this space for a while.
That's right. The organization Health Level 7, or HL7, they've been developing standards for decades. Their earlier versions, like V2 and V3, they became pretty widely used for moving clinical and administrative data around.
Okay, so HL7, V2, V3. They were the standard for a long time.
They were, and HL7 V2 is still operational in many places, but the sources highlight that it was designed for a different time, really, different computing environments. These older standards often relied on more rigid sort of message-based formats.
Rigid messages. What kind of problems did that cause?
Well, things like scaling up easily, that could be a challenge.
Mm.
Or ensuring everyone receiving the data interprets it in exactly the same way. That's the semantic consistency challenge the sources mentioned,
Yeah.
making sure the meaning doesn't get lost.
Right, rigid messages built for older systems, hard to scale, maybe even ambiguous sometimes. And now you mentioned HL7 is still around, so there's a new kid on the block from that same organization, something aiming to fix all that.
Exactly. This is where we get to fast healthcare interoperability resources, which is
Mhm.
thankfully pronounced FHIR.
Ah, FHIR. Okay, much easier to say. And it sounds faster already. So, if the old way was these rigid messages, how does FHIR fundamentally change the game?
Well, the core difference is that FHIR takes a modern web-based approach. Think of it less like sending, I don't know, large predefined faxes between systems
Right.
and more like using the kind of technology your web browser or your mobile app uses to talk to a server today.
Okay, like APIs.
Precisely. It breaks health data down into these modular resources. You can think of them like standardized Lego bricks. There's a resource for a patient's demographic info, another for a specific lab result, one for a list of medications.
Got it. So instead of getting one giant complex message, a system or an app can just ask for the specific resource or piece of data it needs using familiar web requests.
Exactly that. It uses modern web standards like RESTful APIs. This makes it vastly more flexible, more adaptable, especially for integrating with the kinds of applications we all use today, mobile apps, cloud services, things like that.
That makes sense.
And the sources really emphasize FHIR's advantages here. It's designed to be extended as healthcare needs evolve. It offers much better support for developers who are building applications that need this data.
That's key.
And it just aligns better with how modern software is built.
Mm.
The whole point is to standardize and simplify health data exchange. Make it easier, basically.
Standardize and simplify using modern web tech.
Okay. And speaking of modern software and where we spend a lot of our time,
Mm.
our phones, mobile health applications are, well, they seem to be rapidly becoming central to how people track and manage their well-being.
They really are. And this is where Android is building a key piece of the puzzle with something called Health Connect.
Health Connect. Yeah, I feel like I've seen that pop up on my phone.
Yeah.
What exactly is it doing, and how does it tie into this whole FHIR thing?
So think of Health Connect as Android's attempt to create a single central place on your phone for your personal health, fitness, and wellness data.
Okay, like a dashboard.
Sort of, yeah. A central repository. The idea is that data from various apps and devices, your step tracker, your sleep monitor, your nutrition log, can all flow into Health Connect. This gives you a more unified view, and it lets those apps potentially offer richer experiences because they can see a broader picture of your health activities, with your permission, of course. Okay, so it brings together data from my fitness apps, maybe my smartwatch, things like activity, sleep, but how does that connect to actual medical records or our friend FHIR?
Ah, this is where it gets really interesting, according to the sources. Health Connect's capabilities are being expanded. They're starting to include basic medical data. And crucially, this medical data is being integrated using the FHIR format.
Wow.
Within Health Connect, they refer to this as the personal health record, or PHR capability.
Okay, hold on. So Health Connect isn't just for my steps and sleep anymore. It's becoming a potential hub on my phone for actual medical record data, specifically formatted using the FHIR standard. That sounds like a pretty big step.
It absolutely is.
Yeah.
And it's being done in a way that empowers developers too.
Yeah.
With your explicit permission, naturally, developers can securely access this centralized health data and now potentially medical data in Health Connect. They do this through a single set of standardized APIs.
Right. One place to ask for the data instead of connecting to dozens of different apps.
Exactly. And to help them build applications that leverage this, Google provides something called the Android FHIR SDK.
The Android FHIR SDK. Okay, what does that give developers? What's in the toolkit?
So the SDK provides libraries written in Kotlin, which is, the main language for Android development now. These libraries are specifically tailored for building healthcare applications that are mobile first and can even work offline. That's important.
Offline capable, yeah.
And it's all built around the FHIR R4 standard, which is a specific version of FHIR. So the SDK helps developers handle common, tricky challenges, like synchronizing data between the device and backend systems, or ensuring the app functions smoothly even when you don't have an internet connection.
That makes a lot of sense. I mean, building robust health apps that handle sensitive data and need to work reliably on the go, that's not simple. So this SDK sounds like it provides some really essential building blocks for them.
It does.
Yeah.
And these capabilities, they aren't just theoretical or static. The sources point to ongoing developments that are bringing this deeper integration even closer to the user.
Which brings us nicely to what's on the immediate horizon with Android itself. The next major version, Android 16, is already out in developer preview, right?
That's correct. The first developer previews are out. And the sources highlight that these previews for Android 16 include updated Health Connect APIs. These updated APIs specifically add support for these health records we've been talking about.
So what does that mean practically?
Well, it means that applications built for Android 16 will have the ability to both read and write medical records directly in the FHIR format, all managed via Health Connect.
Okay, so this isn't just something Google is, talking about conceptually. It's being actively built into the core of the operating system in the very next version.
Exactly. It's being built and tested right now. It's currently part of an early access program for developers who want to start integrating this capability into their health and fitness apps.
Right, letting them get ready for the public release. And the source also mentioned Samsung's One UI 8 in relation to Android 16. What's the connection there?
Yes. The sources note that because Samsung's next big software update, One UI 8, is expected to be based on this upcoming Android 16, there's a potential for Samsung devices to adopt these new Health Connect features as part of their platform update.
Ah, okay. So it could bring that direct FHIR medical record capability managed through Health Connect to the huge number of Samsung phones and devices out there.
Potentially, yes. It depends on Samsung implementing it, of course.
So while it's not like a confirmed feature for One UI specifically yet, the underlying platform in Android 16 is enabling it. That makes it a distinct possibility for Samsung and potentially other manufacturers building on Android 16.
Correct. The capability will be there in the base OS.
And a really important point is reiterated here again and again in the sources. Accessing this medical data, both reading it and writing it back, requires your explicit consent as the user, every time.
Absolutely. User control remains paramount, which is good. However, with all this power and the potential for really sensitive medical data to be flowing to and from our phones, there's a critical ingredient we absolutely have to talk about.
Yeah, I was waiting for this. Security?
Security, exactly.
Right. I mean, having actual medical data on our phones, the security has to be absolutely impeccable. What do the sources say about the security landscape here? Is it keeping up?
This is where the sources present a pretty significant concern, actually. While the FHIR standard itself includes security principles, the implementation of FHIR, particularly by developers building the apps and the aggregators pulling data together, often shows, well, serious weaknesses.
Uh,
And this leads to vulnerabilities and the potential for unauthorized access to very sensitive patient records.
So the standard itself is designed with security in mind, but the way it's being put into practice isn't always, let's say, following the instructions carefully.
That's a good way to put it, exactly. The research highlighted some common, frankly, basic gaps. For instance, fundamental security best practices aren't always followed,
Like what?
like generally poor security implementations, maybe rushing features out, or even finding things like hard-coded API keys or access tokens directly within the mobile app's code itself.
Wait, hard-coded keys in the app? That sounds incredibly risky, like literally leaving your house key taped to the front door.
It's exactly that kind of basic, avoidable mistake that just opens the door wide open for potential breaches. And given the extreme sensitivity of health data, these security lapses are particularly alarming. The sources really emphasize that security cannot be an afterthought. It needs to be built in from the ground up.
Okay, so what are the absolute essential safeguards that need to be in place then? According to the sources, what does good FHIR security look like?
While they outline several layers of protection, it really starts with the basics, like making sure all data transfers use HTTPS. That encrypts the data while it's moving across networks.
Standard web security, yeah.
Then there's robust authentication, proving who you are, using standards like Oath 2.0 and OpenID Connect. Often this is done within the Smart on FHIR framework, which is specifically designed for securing health app access.
Okay, proving who you are. And what about controlling what data someone or some app can actually access once they're authenticated?
Right, that's crucial. That's where fine-grained access control comes in. It's absolutely vital to apply the principle of least privilege. That means an app or a system only gets access to the minimum amount of data it strictly needs to do its job. Nothing more.
So not just giving it the keys to the whole kingdom.
Exactly. The sources point to using specific FHIR scopes. For example, a scope like patientobservation.read would mean a token only allows reading observation data for a specific patient. It wouldn't allow accessing their entire history or changing data or looking at different types of data the app doesn't need.
That makes a lot of sense. You limit the potential damage if a token is somehow compromised.
Precisely. It limits the blast radius. Beyond that, you need to ensure data integrity, so you know the data hasn't been tampered with. That often involves things like digital signatures or hashing.
Okay.
Data also needs to be encrypted at rest, meaning when it's stored on servers or databases, not just while it's moving. Using strong encryption like AES 256 is recommended there.
Encryption in transit and at rest. Got it.
And critically, implement comprehensive audit logging. FHIR actually has a specific resource for this, the audit event resource, and you need to monitor those logs actively.
Monitoring the logs lets you see who accessed what data and when, right? Helping spot suspicious activity or potential breaches much faster.
Yes, it's your essential digital trail.
Yeah.
The sources also highlight the need for very careful handling of any third-party integrations.
Yeah, connecting systems always adds risk.
And of course, ensuring compliance with regulations like HIPAA in the US or GDPR in Europe, depending on where the data is being handled.
And training.
Yes, often overlooked but essential, is properly training the development and operations teams on secure data handling practices. Security is everyone's job.
Okay, that's a lot on the back end and general practices. Were there any specific security recommendations mentioned for the mobile apps themselves? Since that's where the user interacts.
Yes, absolutely. The sources add some layers specific to mobile security. Techniques like certificate pinning are important. That helps prevent man-in-the-middle attacks, where someone tries to secretly intercept the communication between the app on your phone and the back-end server.
Making sure the app is talking to the real server.
Exactly. API shielding is also recommended to protect the back-end systems themselves from automated attacks, like bots trying to hammer the API.
Right.
And techniques like code obfuscation or hardening the app's code make it much harder for attackers to reverse engineer the mobile app and find vulnerabilities like those hard-coded keys we mentioned earlier, maybe adding app-level authentication too.
So it's really clear that the security side of this is complex. It requires multiple layers of defense, really at every single step of the data flow.
It really is. And the sources strongly underscore that getting security right isn't some kind of obstacle to progress here. It's the non-negotiable foundation. It's what's needed to build trust and actually deliver on FHIR's potential benefits without exposing incredibly sensitive patient data.
Okay, so and it's clear from the sources that this is a big if that requires constant diligence if we can navigate these security challenges successfully. What does securely implementing FHIR on mobile platforms like Android then unlock for the future of healthcare? What's the payoff?
Well, it opens up a wealth of new possibilities, new use cases that just weren't easily feasible before. With standardized, accessible data right there on the device itself, developers can start to build genuinely innovative FHIR native applications.
What kind of applications are we talking about? Can you give some examples from the sources?
Sure. The sources mentioned potential applications like enabling clinical decision support directly on the device.
Decision support on my phone.
Potentially, yes. Using tools like FHR Path or Clinical Quality Language CQL, an app could theoretically process your relevant health data locally, right on the phone, to provide timely insights or recommendations, maybe related to managing a chronic condition like diabetes or hypertension.
Interesting.
It could also enable the calculation and evaluation of certain clinical quality measures using the data available through the app and Health Connect.
That sounds like it goes way beyond just having your data available in one place. It moves towards using that data actively, almost proactively, to help inform decisions or actions related to your health right there on your phone.
Precisely. It leverages the power of modern smartphones. They're incredibly powerful computers now, not just display screens. And the larger vision, as the sources describe it, is really contributing to a broader shift towards more connected, more patient-centered care systems.
Making the patient more central to their own care.
Exactly. The ultimate goals are improving individual patient outcomes, making healthcare safer and more effective for you, and also driving greater operational efficiency across the entire healthcare system by making data flow much more smoothly and, crucially, securely.
It definitely paints a compelling picture where your phone could become a much more integrated and powerful tool in managing your own health journey.
It really does. It's fundamentally about putting you more in control of your health information, making it accessible and actionable securely through these evolving standards like FHIR and the mobile technologies we use every day.
So let's recap. We've taken a deep dive into this challenge of fragmented health data. We explored how the FHIR standard is emerging as a modern, flexible solution built on familiar web technologies.
Making data exchange easier and more standardized.
Right. We saw how this is making its way onto our phones through Android's Health Connect, with exciting future developments coming in Android 16 that could enable reading and writing FHIR medical records.
Potentially reaching many users through platforms like Samsung's One UI.
And critically, we emphasize the absolute necessity of robust, multi-layered security to protect this incredibly sensitive information. That trust is paramount.
It's clear there's incredible potential here, but realizing it depends entirely on diligent, secure implementation and maintaining user trust every step of the way.
Absolutely. And that leaves us with a final thought for you, the listener, to consider. If your complete secure medical history could one day be accessible and shareable from your phone entirely with your consent, how might that fundamentally change the way you manage your health? Or how you interact with your doctors and other healthcare providers? What new possibilities does that unlock for you personally?